Okay, I'm gonna go over the speed, velocity, and acceleration problems that I gave you guys for homework. And yep. Hopefully you guys can double check your answers. Okay, so speed of light is 3.0 times 10 to the 8th meters per second. So that's my speed. I'm not gonna write it on the side like I usually do because these are long numbers. How long does it take light to reach us? So how long does it take? So I'm looking for time. And the distance is 152 billion meters away. Okay, so here's the equation that I know. Now remember, we can rewrite this equation by moving things around. I can multiply the t on the other side so that I have distance equals speed times time. And if I want to get time by itself, I divide speed on both sides, so time equals distance divided by speed. So when you're looking for time, you can take the speed equation, just switch the speed and the time around. Okay, so time equals distance divided by speed is what I'm going to use for this one. So got my distance. Sorry you guys hear all the tapping while I write. I'm sure it's very annoying, but gotta pick my pen up. Times 10 to the 8th meters per second, and this is in meters. Don't forget your units. Okay, so we have meters on the top and we're dividing by meters per second on the bottom, so the meters are going to cancel each other out. So I'm going to end up with 506.67 seconds. Number 2. A tennis ball travels the length of the court, 24 meters, in 0.5 seconds. Find its average speed. So I'm looking for speed. I know my distance is 24 meters, and my time is 0.5 seconds. So I know my equation, right? Distance over time. So 24 meters divided by 0.5 seconds. And my 5 looks like an S. So if you slash like this, you know that this part is your units and this is your answer. The answer is 48 meters per second. How far will you travel if you maintain an average speed of 10 meters per second for 40 seconds? So how far, that's going to be distance. We're looking for distance. The question is asking for distance. I know my speed is 10 meters per second, and my time is 40 seconds. So again, like I said, we can rearrange the equation. So I'm going to use distance equals speed times time. And I just rearranged that from my speed equation that I already have, right? That we have in our formula chart. So distance equals 10 meters per second. Actually, I'm going to draw it like this. So this seconds right here is on the top, and this second right here is on the bottom. So that's going to cancel each other out. So my distance is going to be 400 meters. A regular jet flying at an average speed of 530 miles per hour travels round trip from New York to London and back in 14 hours. What is the distance between the two cities? So I know I'm looking for distance. I know my speed is 530 miles per hour, and my time is 14 hours. So again, I'm going to use this rearranged speed equation. Distance equals 530 miles per hour times 14 hours. The hours cancel each other out because this per hour is on the bottom, right? So my distance is going to be 7,420 miles. But look at the question. This was round trip, okay? The whole trip was there and back. It's only asking for the distance between the two cities, not how long it went round trip. So basically it's, well, if it was displacement, it's 0. So it's asking actually for half of this number. So I'm going to divide this by 2. So the answer is going to be 3,710 miles. Okay. If a train is going 952 miles in 12 hours, what is the train's speed? So I know I'm looking for speed. I have my distance, 952 miles. And I have my time, just 12 hours. I apologize again for my dogs. So speed equals distance divided by time. This is what miles per hour looks like in fraction form instead of just writing mph. Okay, so 79.33 miles per hour. You guys be careful about rounding too much. We don't really ask in the questions to round. We also haven't talked about significant figures, so just stick to, I don't know, the second decimal place seems good. Okay, next. I got some stray marks. Okay. All right, if your car is going 30 meters per second and comes to a stop in 4 seconds, what was the acceleration? So I know I'm looking for acceleration here. It was going 30 meters per second and then it stopped. So 30 meters per second is going to be my initial velocity. Final velocity is going to be 0. And this 4 seconds is my time. So remember, or look at your formula chart, and you can see that acceleration equals final velocity minus initial velocity divided by change in time. The delta symbol just means change. In this case, it was 4 seconds. So I can plug all this goodness into my equation. Not have to rearrange a thing. So final minus initial divided by 4 seconds. And my answer is negative 7.5 meters per second squared. Remember, meters per second squared is the same thing as meters per second per second. So I have meters per second right here, and then I'm dividing it by another second, so, or another unit of seconds. So I'm adding the second per second, because this division sign is basically per. Remember, miles over hours is the same thing as miles per hour. So meters per second over seconds is meters per second, or meters per second squared. I hope that makes sense. Okay, next. If a train is moving at 100 meters per second and slows to 30 meters per second in 20 seconds, what is the train's acceleration? So I know I'm looking for acceleration. I was initially moving at 100 meters per second, and then I slowed down to 30 meters per second, and I did that in a time of 20 seconds. I'm going to plug all that into my equation. 30 minus 100 meters per second. And I'm putting the units on the outside because they're both meters per second, so that applies to both of them. Without me having to write it twice, divided by 20 seconds is going to be negative 3.5 meters per second squared, or meters per second per second. I was running 6 meters per second when a noise spooked me, and I sped up to 7.5 meters per second in just 2 seconds. What was my acceleration? So again, change my color here. Let's make it a nice pink. So again, I'm looking for acceleration. My initial velocity, it says I was running. So initial velocity is 6 meters per second. Then I sped up to 7.5 meters per second in a time of 2 seconds. I'm a super fast sprinter. No, that's not that bad, I guess. But anyway. So again, I can just plug this in. This one's not too complicated. Final minus initial meters per second over 2 seconds. And just do some calculations. 0.75 meters per second squared. Okay, so this answer was positive because I went from a lower to a higher velocity, whereas these ones you were slowing down, so your acceleration is actually going to be negative. And if you were looking at that on a graph, it would be a curve going downward, whereas a positive acceleration would be a curve going upward. Okay, I am driving at 76 meters per second when I hit the brakes and decrease my speed by negative 9 meters per second. How fast am I going in just 4 seconds? So I'm actually looking for, since we got acceleration, so I know my acceleration, negative 9 meters per second squared. I got my time, which is 4 seconds. And I have my initial velocity because I was going 76 meters per second. And now I'm looking for my final velocity, okay? So I'm just going to write it out without rearranging the equation because it just works out easier this way. Minus velocity initial, which was 76, divided by 4 seconds. So I'm going to multiply both sides by 4 seconds. I'm going to have velocity final minus 76 so these cancel, right? Equals negative 36 and then I can add the 76 to both sides. So the final velocity is 40 because this is a negative. Okay. Drop an apple off a building. Keep trying to put apple and off together. The acceleration due to gravity is 9.8 meters per second squared. How fast is the apple going after 5 seconds? Okay, so you're dropping it. Now, when you're holding the apple at the top of the building, it's not moving. So my initial velocity is 0. I'm looking for how fast it's going to be going after 5 seconds. So I'm looking for my final velocity. In 5 seconds is my time. And my acceleration of gravity, which we will learn more about next unit, is always going to be 9.8. I think it's actually 9.81. 9.8 meters per second squared. So plug that in. Okay, I can multiply the 5 seconds on both sides. And I'm going to get 49 meters per second because this, minus 0 is nothing. So this is just final velocity. Okay, almost done. I'm trying to make this faster than the last one because that was a little long. I am riding my bike at 25 meters per second. I start to slow down at a rate of -4 meters per second squared. I slow down for 5 seconds. So I know my time is 5 seconds. I'm going to write that before I forget it. My initial velocity before I started slowing down was 25 meters per second. And my acceleration was -4. I know we think of acceleration like cars accelerating, and that's true, but acceleration can be positive and negative, so just get used to keeping that in mind. Okay, so what is my final velocity? That's what we're looking for. Final velocity. So -4 meters per second squared equals velocity final minus velocity initial. Over a change in time, which is 5 seconds. So again, multiplying the 5 on both sides. We have velocity final minus 25 meters per second equals, I'm just moving it to the right side because that's how I like to do things. Squared. And then I just add, oh wait, I multiplied by seconds, so that's actually going to get rid of that square. Sorry about that. Plus 25 meters per second on both sides. You can't add two things that aren't the same units. So if that had been meters per second squared and this 25 over here had just been meters per second, I couldn't add them together. But since I multiplied this side by seconds, it's actually going to cancel out one of those seconds on the bottom of that unit, this unit. Okay, so my final velocity, and I'm sorry I'm running out of space like this, is 5 meters per second. Okay, last but not least, let's do something pretty for this one. Ooh, purple. Okay, my race car is going 120 meters per second as I cross the finish line. I was accelerating at the end of the race in order to win. I accelerated at a rate of 9 meters per second squared for 3 seconds. What velocity was I going in when I started to accelerate? So we're looking for initial velocity. Because we have the final velocity. As you cross the finish line, it was 120. We have the acceleration, which was 9. And we have the time, which is 3 seconds. All the space I had to just scribble all over. Okay, so 9 meters per second squared. Final velocity minus initial velocity, unknown, divided by 3 seconds. Multiplying the seconds on both sides. So since we're multiplying that, it's going to get rid of this square. We're going to have 27 meters per second equals 120 meters per second minus velocity initial. So you can subtract the 120. You're going to have negative 93 meters per second equals negative velocity initial. And obviously you have to switch the signs because you have a negative sign in front of an X. So initial velocity, 93 meters per second. Okay. I hope you guys found this helpful. Hopefully you got all the answers correct without me even going through it. And I'm sorry about my handwriting. I'm sorry about all the spare noise. And I'm sorry this took so long. Yeah, good luck on the